Good afternoon, my YouTube viewers. It is Crystal here, and what I wanted to do is I wanted to do a code review for you. But before I do the code review, I wanted to first go through some statistical concepts. And because if you know the statistical concepts, then it'll help you better understand the code in R and also Python. So first thing we're going to do is we're going to talk about the Pearson's chi-square test. Pearson's chi-square statistical hypothesis is a test for independence between categorical values. In this article, we will perform the test using a mathematical approach and then using Python's SciPy module. Let's first see the mathematical approach. So I'm not going to go over the mathematical approach. You can do that on your own time. But basically, you've got your contingency table, and we're going to be going over the contingency tables when we go over the code. So this is your contingency table right here that you need to look at. And this is an example of men, women, and whether they have dogs, cats, or birds. So we'll go through the mathematics. And then what we do is we'll just look at the code. Hence, we need to compare the p-value with an alpha of 0.05. And so that's the code, an example of the code that we're going to be using in our code review. So the next thing we'll do, just to give you a little bit more insight into this Pearson's categorical test, you got how to form a chi-square test of independence in Python, because that's what we're going to be doing. It says a chi-square test of independence is used to determine whether or not there is a significant association between two categorical values. And then it gives you a tutorial as well. So you've got your tutorial, you've got your little table of males and females, and whether they're Republican, Democrat, or Independent. And then you create the data. So the data is going to be created, and you do one row, and then you do the next row. Okay, and then you perform the test. And then there's a sample code for the test that you can look at. So there we go. There's an example of giving you two examples of Pearson's chi-squared test for independence. So what we'll do here is I'm going to show you where I got the questions. I got the questions from this YouTube video right here. And so statistics and probability full course, that's where I got the questions, just in case you wanted to know where I got the questions. And then so now what we're going to do is we're going to start with R, because this particular YouTube video, it discusses R, and then I translated it over to Python. So it's done differently in R than it is Python, so I'm going to show you how to do it both ways. So the first question is, I would like to test if there is a significant relationship between whether a person has blue eyes and whether that person is an MNS major. That's Mathematical Natural Sciences. To test this, I ask 100 people at Knox and measure if they have blue eyes and if their major is MNS. So you have to build a little table that the rows are going to be MNS, not MNS, and the columns are going to be blue, not blue. So people who were in MNS with blue eyes were 7, and people doing MNS with not blue eyes were 28. People with not MNS with blue eyes were 13, and people with not MNS and not blue eyes were 52. And then so you look at the matrix. So the first thing you do is you have to create a matrix, and it's got 2 columns. And so you do see chi sq dot test obs, and then that gives you a p-value of 1. So we come over here to Python because we translated it into Python. You've got exactly the same question, exactly the same matrix. And so we imported scipy.stats as stats, and then we created a matrix called data. And so you go by the rows. So you do row 1 and then you do row 2. So row 1 is 728, row 2 is 1352, and you use stats, comma p, comma dof, comma expected equals stats.chi2 underscore contingency data, and you check your p-value, and you got a p-value of 1. So that p-value is identical to the p-value that we had in R, and that's what we want to look at. So now we go to the second question. I would like to determine if the proportion of males who wear hats is the same as the proportion of females who do. To test this, I sample 100 males and 100 females. 10 males and 16 females wore hats. So then we have to make a little table again. So you can tell that I copied and pasted. So you can tell I copied and pasted off that. So you have the first row is females, and so you had 16 more hats and 84 didn't wear hats. And the second row is males, and you had 10 more hats and 19 didn't wear hats. And then so what you have to do is you have to create a matrix with these with the data, but instead of doing it by rows, you have to do it by columns. So obs equals matrix bracket C brackets 16, 10, 84, 90. The number of columns is 2. And then you do chis_q dot test obs, and your p-value is 0.2931. So we come over here to Python, and you can see, because in order for me to make this, I copied and pasted it, and so you can see that I copied and pasted it. So the exact same question, and we import scipy.stats as stats. So we had to create a matrix, a 2x2 matrix with that data. So the first row is 1684, and the second row is 1090. And then stats, comma p, comma dof, comma expected equals stats.chi2 underscore contingency data, and we check our p-value, and your p-value is 0.2931, which is what we wanted to see. So now we come over here to the third question. I would like to determine if females have different grade distribution in Stat 200 course than males. So we had to, you had to use all of the course data from this particular instructor. So females had 57A, 72B, 61C, 40D, and 22F. And males had 49A, 68B, 55C, 32D, and 20F. And then so what you had to do was you had to create a matrix, obs equals matrix, bracket C, bracket, so it's 57, 49, the next row, next column, 72, 68, the next row, 61 is the next column, 55 is the next row, 40 is the next column, 32 is the next row, 22 is the next column, 20 is the next row, and you see you've got 5 columns. And so choose Q.test obs, and that gives you a p-value of 0.9851. So one thing that I can tell you is all of the p-values in R was above the alpha of 0.05, and so since it was above the alpha of 0.05, it meant that you had to accept the research question. If the p-value had been less than the alpha of 0.05, then you would reject the research question. So now what we do is we go over to Python, and you can see it's exactly the same question. And then you import scipy.stats as stats, and then we create our matrix. And this is a 2x5 matrix, but this matrix is done differently because the first row is the rows in the first row of the table, columns in the first row of the table, and the second row is the columns in the second row of the table. And stat, comma, p, comma, dof, comma, expected equals stats dot chi2 underscore contingency brackets data, and you get a p-value of 0.985108, which is exactly what we had in R. So in this particular example, we didn't have any questions where the p-value was less than 0.05, but if the p-value had been less than 0.05, they would not have been able to accept the research hypothesis. They would have to reject the research hypothesis and go with an alternative hypothesis. So that's it for this particular code review. We've covered the questions and given you the code in both R and Python, so you should be happy. And I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you very much for watching my code review. I look forward to making more code reviews for you in the future.